My topic is about basic applications of directive. In this chapter, has an important rule is y minus y1 equal m multiply x minus x1. In this question, first we have to get the directive y equals 3x squared plus 2x. Then we put x equals 3 in the directive of y, get the slope m equals 33. Then put slope m and the point in the room y minus y1 equal m multiply x minus x1. Then we get the equation of the tangent line is y equals 33x minus 63. This question has the same way about the example. First we get the directive of y. Then we get directive of y is 10x. Put x equals 3 in, get the m equals 30. Then follow the rule, get the equation of the tangent line is y equals 13x minus 45. First is to get the directive of y equals negative 3 minus 2x. Then we put x equals 0 in, get the slope m equal negative 3. Follow the rule y minus y1 equal m multiply x minus x1, get the tangent line is y equal negative x 3x plus 4. In this question, we should follow the rule of directive y is directive fx multiply gx minus fx multiply directive of gx over gx squared. Then we get the directive of y, put x equal to in the function. Then we get m equal negative 6 over 5. Then the tangent line is y equal negative 6 over 5x plus 22 over 5. The level 2 is that we only get the x equal negative 1 but not the point. So first we have to get the point. When x equal negative 1, we get the x equals 6. So the point is negative 1, 6. Then get the directive of y equal negative 1 minus 2x. But we should know the question asks us the normal line but not the tangent line. So we get the m is tangent line. Have to put the negative before the m. Then we get the slope of m of the normal line is negative 1. Put the normal line slope in the room is. Then we get the y equal negative x plus 5. This question is a little bit easier than the example because we saw the tangent line but not the normal line. First, we put the x equal 1 in the regular function, get the y equal negative 7 over 2. Then put x equal 1 in the directive of y, we get the slope of m is negative 9 over 2. Get the all information, then we can do the last step is y equal negative 9 over 2 plus negative 2 x plus 1. The same way we put x equals 3 in the normal function, then we get y equal 24. Get the point, then find the derivative of y is 6x minus 1. Get the slope of m is 13. Then put all the information in the room. Get the tangent line is y equal 13x minus 27. Put x equals 3 in the regular function, then we get y equal 18. Then solve the derivative of y is 3x squared minus 3. Then put x equals 3 in. Get the slope m is 24. Put all the information in the room. We get tangent line is y equal 24x minus 54. In this example, we know from the question is the tangent line parallel to the x line, so we can know the slope m equals 0. Then we get the slope m is derivative of y 6x squared minus 6x minus 12, let it equal 0. Then we get 2x. 1 is 2, 1 is negative 1. Put all of the x in the regular function, then we get the 2 point. The 2 point is 2, 0, and negative 1, 27. From the question, we know the slope is y equal x, so slope m equal 1, and the next step is to find the derivative of y. Let it equal 1, then we get the x. The same way of the example, find the parallel to the x line. We can know the slope m equals 0, then get the derivative of y. Let it equal 0, then we get the x equal negative 3 over 2. Put the x in the regular function, then we get the point. The question only needs us to find the values of x, so from the question we know it's the parallel to the x line, m equals 0, then get the derivative of y is 2x minus 18, let it equal 0, then we can get the x equal 9.